O is the point of intersection of diagonal AC and BD of trapezium ABCD, with AB being parallel to DC. First thing first, when you don't understand what you're reading, draw a diagram. So we're looking at a trapezium. So it's not an isosceles trapezium. There is no indication of that. Okay, I'll draw something like this. Okay, just a second. Yeah, that's okay. So we have what and all? We have ABCD. So AB is parallel to DC. So that's not it. ABCD. So AB is parallel to CD. And what else? We have the diagonals intersecting and all of that. So this and this. So they're meeting at O. Then what else? What else? What else? Through O line segment, PQ is drawn parallel to AB. So we have something like this. So we have PQ, which is parallel to AB. So by default, it's parallel to TC also. So let's start off by writing what is given. And also, what is that we have to prove? Oh, we have to prove that this length is equal to this length. It is so, right? I mean, technically it has to be. And the diagram also, it looks to be so. Basically, O is the midpoint for this particular line. Okay, so let's start off by writing the given. So we have AB being parallel to DC, and we have PQ parallel to AB. Therefore, PQ is parallel to DC. We will be using this, right? So as line, not as line parallel to lines parallel to the same line are parallel to each other. Are parallel to each other. That's given. We have to prove PO is equal to QO. Now, how will we relate PO and QO? It has to be with what concept can we use? We can't use BPT. It has to be with similarity, right? So which and all triangle should we consider? One has to be APO for sure, and other BOQ for sure. So this by default, you guys know, is similar to ADC, and the other one will be similar to BDC. Right, something like this. So how will we go about doing it is something that we have to figure out. First, let's write this much. I told you always write what we know for obvious, to be obvious. So the proof, consider triangle APO and triangle ADC. So again, we are writing things which are obvious, right? Let's continue that. We have angle A to be common. Then we have angle APO, which is equal to angle ADC, because of reason being PO is parallel to DC, right? And they are alternative interior angles. And then we have by AA similarity triangle APO is similar to triangle ADC. So by CP ST, what is that we are looking at? AP by AD is equal to PO by DC is equal to AO by AC. Okay guys, we'll call this as equation 1 later on. Next is we'll consider the triangle. Consider triangle OBQ and triangle DBC. So we have angle B is common. We have angle BOQ, which is equal to angle PDC. Same reason, not PQ is parallel to DC and they are alternative interior angles. And so we have which color? By CPST, OB, I think I wrote the order right. Okay, I've written the order right. OB by DB is, oh yeah, sorry, first I have to write they are similar now. By A similarity, what do we have guys? Triangle OBQ is similar to triangle DCB. Wait, what? DBQ, sorry. DBC, not Q. And now we can write the ratios properly. So we have OB by DB is equal to OQ by DC is equal to BQ by BC. Right? OB, DB, OQ, DC and BQ and BC. Okay, so we wrote the obvious. Let's look at how we can relate them. So we have, where is it? This to be equal to this. So we have DC common. So cancel, equating them, we are done. Right guys, if I equate this to, we are done. But how do I relate this to is the question. This has to do with one of the questions which we have done before. We need to find a common ratio. AP by AD is equal to AO by AC. But AO by AC is also equal to BQ by QC. Sorry, AO by AC is equal to BQ by BC. How will we prove that though? We have to take which triangle? Think of it. Yes, we have to go with the other end. So let me clear this up so that you guys can get a good idea. So now we have to relate these two expressions. So the only way we can relate is if I get a ratio for AO and AC or something like that, right? So how will I get a ratio for AO and AC? With the help of triangle, this triangle, and at this end we have BQ and BC. Okay, so basically we have to do something like this. This triangle, that's the only way, right? And this triangle. There, it looks to be that we'll have to use some math after that. We'll do that, no worries. Let me copy this though, because it will be tough for me to go back and forth, and you guys will also get a headache. Okay, no, let me not do it over there. Okay guys, different layer, it's safe. Okay, now, so it's kind of obvious, again the same set of writing, there's nothing new to this. So we'll start off with consider triangle OCQ. Guys, we have done such questions, just that we have seen it in a different form. And triangle ECB. So same set of writing. Angle C is common. Actually not C per se. Oh yeah, I can't write B over there. OCB is common. And this also I'll change. You can't write that way. DC TBC. And here is not angle A, it is DAC. OCB is common. Then we have, what else do we have? Angle CQO is equal to angle CBA, right guys? We have AB being parallel to BQ, and these are alternative interior angles. And then we have by AA similarity, triangle OCQ is similar to triangle ACB. And now the ratio, just write everything. OC by AC is equal to OQ by AB is equal to CQ by CB, right guys? This and this, this and this, and the other one. So we are looking at something to relate all of this, right? So we have BC and CQ, not BQ. And this and this I'm talking about. And over here we have AC we have, but see this and this. So how to do this? Let's consider this two expressions. We have AC by OC, or OC by AC is equal to CQ by CB. So what is the math that we have to do? I think we should subtract in this manner. With this, we'll get the other part, and we'll be able to get this expression actually. I'll show this, then you guys will understand. So, okay, let's consider OC by AC being equal to CQ by CB. Then I'm going to multiply throughout with -1 and add 1 to it. So let me do this. Multiply, or let me write a statement. Multiplying 1 minus 1 on both sides and adding 1 to it on both sides. Could have just written multiplying 1 minus 1 and adding 1 to both sides. Why? You'll see now. This is a bit of math that we have to do. So what will happen, you guys will see. So we have 1 minus OC by AC is equal to 1 minus CQ by CB. Now if I take the LCM and all of that, it will be AC minus OC by AC, which is equal to CB minus CQ by CB. So this would be what? AC minus OC. AC minus OC is AO. We have AO by AC, which is equal to CB minus CQ. CB minus CQ is BQ. BQ by CB. Okay guys. Now we have this particular expression. See this. Let me use something like an highlighter. So we have, or with white, that will be good. So we have this being equal to AO by OC, whereas AO by OC here. Since these two are equal, what can you tell about this two ratio? They are equal, done. Is it not? All we did was we went with triangle 1 and 2, triangle 1 and triangle 2, triangle 1 and triangle 2. We just wrote the similarity up right and center, and then did a bit of math, and then we got the required things. So I'll be honest about this. I had a different approach before, but that didn't work out. This is my second attempt. Okay guys, this is how I figured it out. So yes, not all the question will be kind of obvious at one go. But yeah, writing the obvious things till this point was something that I was able to do. And I had to use a pen and paper to figure out how do I relate all of this. But till this point, to be honest, it was just writing. And you guys saw me, I didn't do anything special. I just kept on writing similarity stuff. So now all we have to do is calling this as 1, 2, and 3. This is 1, 2, and 3. So from 1, 2, and 3, what can you tell? All of these ratios are to be equal to each other. Therefore, from 1, 2, and 3, we have OQ DC is equal to, what is that we have to prove? PO by DC, PO or OP by DC, and this, all of this is equal to this particular expression, PO by AC, which is equal to VQ by CB. So we have therefore OQ by DC is equal to PO by DC. So what is common in both the ends? DC and DC. This implies OQ is equal to PO. Hence proved. Okay guys. Lot of writing, but yeah, it's a simple question in some sense, but I'll rate it as level 3. Okay, so here the only thing is this part, which is pretty new. Right? This is something I figured it out on a pen, on a sheet of paper. If not, it's something that it will take time to think. That I agree. I'm not going to make it to be very easy. But yeah, writing the first few things is easy. That is true, is it not? And that is almost your 60% of your answer. Okay, any hard question you will be able to write the obvious things. Just use common sense. I want to relate PO and OQ, and this are all this are parallel. We are looking at BPT. So BPT is also, actually, oh yeah, we can use BPT also. That would have been shorter. Oh no, you won't be able to relate PO and OQ. Anyways, that's the whole point. That's why I took similarity. See, common sense. So if you think and do it, you should be answering your own questions. Like I was just confused. Why didn't I use BPT? Again, it will be some way we can use, not that we can't, but somewhere along the line we have to use similarity also, because we have to relate PO and everything else. PO and OQ can be related only with similarity, right? That's one of the possibilities. Okay, so now you can pause and have a look at the answer.